All right, hello geometry students, and welcome to lesson 212, where we're looking at more angle relationships, but now these are going to be ones that are formed by what are called transversals, and we're going to look at parallel lines today and some of the parallel line angles that were talked about. So if you remember back to lesson 211, I'm not going to go through this because we did it in the in-class version, but here we're trying to figure out which one of these have equal measures, which ones of these pictures are complementary, which remember have a sum of 90, or supplementary, which have a sum of 180. Or the other idea is that they're vertical. Okay, we talked about this the other day in our in-class, so I'm going to skip over this problem. This is just a review of where we were, okay, of the last lesson. So let's take a look at where we're headed today. So Marcos was walking home after school thinking about special angle relationships when he happened to notice a pattern of parallelogram tiles on the wall of a building. He saw a lot of special angle relationships in this pattern, so he decided to copy the pattern onto his notebook. The beginning of the diagram is shown at the right, and will be on the next page. I have the resource page. The type of pattern is sometimes called a tiling. Remember, we also talked about like as a tessellation. So in this tiling, a parallelogram is copied and translated to fill the entire page without any gaps or overlaps. Since each parallelogram is a translation of another, what can be stated about the angles in the rest of his tiling? So it says to use a dynamic geometry tool or tracing paper. We're going to go through and I'll just do it here together. And it says color all the angles that must be equal the same color. Okay. And then we're going to take a look at kind of the rest of the idea here. So let's take a look. So here is the actual page that we have here. And what we're looking at is I'm going to start to color in a certain angle here. So if I put a dot right there, and we go through and we translate this. So if our translation is here, let's say we translate it up. Well, notice that means this right here then, that angle is going to be the exact same. If I do it again, that angle will be the exact same. Then if I start going the other direction, if I slide this over here, that means this angle will be the same. Same thing down here for the bottom one. If I keep going, same thing here. Okay, and then if let's say I slide it down on this last one, all of those red dots have to be the exact same angle because it's the exact same parallelogram in every one of those shapes. Okay? So now, if I go through and I start taking a look, let's say we now add in the idea of some vertical angles like we talked about before. Okay? So that means if this angle right here is an angle that we're looking at, that means the vertical angle, the one diagonal, also has to be the same. So that means this angle must be the same color. And then we could go through and kind of do that, the same idea as well. So now if that's the same color, that means that this one must be, because I can translate it. I can translate that to the right over here. I can translate that down. So basically, I hope what you're noticing so far is that the bottom left and the upper right of each one of these angles has to all be the same. Notice I put red dots in all of those. Okay, now if we pick a different color, let's say I go with green, and let's say I pick this angle right here. Same thing, translate it up, that's going to be the same, that one's going to be the same, translate it to the right, that's going to be the same, this one's going to be the same, okay, this is going to be the same, translate it down, there we're at. Then if we just add in the idea of vertical angles, here's a vertical angle, there's a vertical angle, here's a vertical angle, here's a vertical angle. Okay, and then we can do a couple of translations as well to kind of finish this picture off. So if you notice, I ended up with only two colors in this entire picture. Okay, so if I take a look back now, it says consider the angles. Which angles must have equal angle measures and which why? So what's the relationship between the lines? Can you identify any lines that must be parallel? Okay, so if we take a look, remember these are parallelograms. So by definition, these are parallel lines. So that means this line must be parallel to that line, must be parallel to that line, must be parallel to that line. Okay, same thing over here. Parallel, 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 all the way down. Okay, so those have to be parallel. Then if we go with a different color, these also have to be parallel, otherwise it's not a parallelogram. Okay, so if I put a couple of markings on there, There's some extra parallel lines. Okay, so we've got a whole bunch of parallel lines, a whole bunch of congruent angles, and if we keep going, let's take a look here. So if you notice, it says Julia then wants to learn more about this diagram, and so did an enlarged view of the section. And so here's where we're going to take a look. Here's our first, let me get the highlighter out. Here's the first terminology, first vocab word. A line that crosses two or more other lines is called a transversal. So the one that goes through the parallel lines is called the transversal. Okay? And what we're taking a look at, if we go down here, notice it says trace angle X on tracing paper and shade its interior, and then translate it down. So if I go through and I take, oops, let's get rid of that. That's not what I wanted. Let me undo that. All right, let me go back to the pen here. So if I take a look at this angle X right here, and I translate it until it lies on top of another angle and matches exactly, what hopefully you can see is that if I take this and I just slide this angle, I'm going to actually highlight that piece right there. If I slide that angle up this transversal, hopefully what you notice is it falls right into place right here. Okay? Angle B and angle X are the exact same measure. There's a translation that goes right up that transversal. Okay? Those angles, I'm going to go back to my highlighter. If we take a look now at part C, those angles are what are called corresponding angles because they're in the same position at two different intersections of the transversal. So angle X on the bottom corresponds with angle B on the top. Okay? And notice it says, what's the relationship between the measures? Well, if they fall in this exact same spot, that means they must be equal. Okay. Otherwise, it's like a puzzle piece fitting in. Otherwise, that wouldn't fit together. Okay. If we keep going, so then it talks about using that idea, okay, and it asks to name the other corresponding angles. So let me go through and take a look at those different ones. Okay. So we already said in this problem that angle X corresponds. If I slide that up, that would correspond with angle B. Those have to have the same measure. Corresponding angles are equal. If I switch to a different color, let's say angle W right here. Well, if I take that and slide it up the transversal, that would fall right in place right here, angle A. So angle W and angle A are another set of corresponding angles. If I go to a different color, let's say I choose angle Y, do the same thing. If I slide that up the transversal, that would fit right into place here with angle C. Those have to be equal. And finally, if we go to one final color here, angle Z, this angle right here, would slide right into place right there. So you have four different sets of corresponding angles in that case. Okay? And then in part B, they said, suppose that angle B equals 60. How could you go through and find the other ones? Let me go through and actually change the colors here. If this is a 60-degree angle right here, that means when I slide it down, this is going to be 60. Then if I go through and use vertical angles, that means angle C is going to be 60 because it's vertical with angle B. Slide that down, that means angle Y is 60 degrees. And now if I use supplementary angles at the top up here, angles A and B are supplementary. They add up to be a straight line, a straight angle. So that means this is 120, okay? Which also means angle D is 120, either because of supplementary angles or because it's vertical with angle A. And now if we do a couple of translations, that's got to be 120. That one's got to be 120. Okay, so that's what we're taking a look at. Adding in some corresponding angles is the idea. So now, if you notice in problem 217 here, says that Frank wonders whether the corresponding angles always have to be the same. Okay, and so the idea behind this is they ask you to use tracing paper. We're just going to go through and just use kind of our eyesight here, if you will. So if I take this 135-degree angle and I slide it down this transversal, the question is, does it match up with that one? The answer is yes. So that means that's 135. Okay. In part B, if I take a look, 135 and Y, those are supplementary angles. So that means they have to add up to 180. They give you a straight angle, a straight line. So that means 135, if I take that away from 180, that would be a 45-degree angle. And the question is, if I take this angle and slide it over, would it match up with this? And I think it's fairly obvious. You can see that the answer is no. Okay, so there's actually no way to find angle X in that one. If we go down here now to part C, 135-degree angle. If I take that one and slide it down this transversal, it does fit right in the place. So this is 135 degrees. And then X and Y are supplementary angles. So therefore, if you put those two together, you get a straight angle 180. So that means angle Y has to be 45 degrees. Then in part D, the final one that we're going to take a look at, X and 135 are supplementary. They add up to a straight line. So that means this is 45. But then the question is, can I take that angle, slide it down, and would it match up perfectly with this angle? Okay, or even angle X, could I slide that down? And again, the answer is no. And what they're trying to get at in this problem, if you notice in part E, it says, do corresponding angles always have equal measure? And the answer is no, they don't. Okay, and hopefully what you noticed in this problem, when were we able to slide things and have equal measures versus when were we not able to? And here's the key part right here. This one you had parallel lines, therefore it worked out. This one you had parallel lines, therefore it worked out. Both in B and D you did not have parallel lines. So in this scenario, when it says to write a conjecture about what's going on with corresponding angles in terms of a conditional statement, by the way, let me again put a little highlight on this one. So a statement in if-then form is called in a conditional statement. Okay, so just a heads up, anytime you hear like an if-then type of problem, that's a conditional. If the first part is true, then the second part, okay, would follow. So now the idea is they want us to actually make a conditional statement. Okay, and what we found out is if lines are parallel, that was the key condition. If lines are parallel, then corresponding angles just going to abbreviate angles. Corresponding angles are equal. Okay, but only if lines are parallel. Okay, and that's what we saw up above here in these pictures. That's what we were looking at. When they're parallel, then corresponding angles are equal. Okay, all right, let's keep going here. If we take a look, now we're going to go through and kind of try to use this concept to see if we can come up with an answer. So if we notice in the first problem, part A, notice I do have some parallel lines here. That means I can slide this 115 right over here, and that works. I slid it from one parallel line to the other. Then if you notice, I have another set of parallel lines, so I can also take that 115 and slide it up right here from one parallel line to the other. Those are corresponding angles. And then this last 115 and angle X, those are supplementary, which means they have to add up to 180. So we end up with a 65-degree angle as our answer for X. Okay. In part B, notice I do have some parallel lines, so I can take that 53 and I can slide it over here. That means this has to be 53 from one parallel line to the other. But then you run into a problem because now this top line right here and this one is not parallel, so I cannot take that 53 and slide it down here because I do not have parallel lines. So that one doesn't work. Then if we take a look at part C, now we're getting into some algebra as well. Again, notice parallel lines. That means I can go from the top parallel line and I can slide it down to the bottom one. So this 4x minus 25, I can slide that right down into that spot. It's got to be the same. That's corresponding. Then if you notice, I have another set of parallel lines. So that means I can also go from this parallel line here and slide it over to this parallel line. So that means that this is also 4x minus 25. Okay. And now if you take a look, this angle right here that's 4x 25 minus 25, and this angle right here that we've got labeled as 3x plus 10. Those two angles are vertical angles, and therefore we know from the last lesson that those two have to be equal to each other. So 4x minus 25 equals 3x plus 10. And now we start moving stuff around. Solve the equation. I'm going to subtract the 3x. Since the x's are moving to the left, that means I'm going to add the 25 over here to the right. Okay, 4x minus 3x gives you 1x. Positive 10 and positive 25 give you a total of x equaling 35. And in this problem, they did not ask you for any angle measures, so x equals 35 is your final answer. Okay? So that problem, if you notice, we used corresponding angles and vertical angles from the previous section to solve for x. Okay? And that's kind of the idea. That's where we're headed, is we're going to start using all these angle measures and keep building on things. Okay? If you take a look here, this is, I'm going to highlight a few things on this one. This math notes box just talks a lot about naming different shapes. Okay? Because if you notice at the top, part of geometry is the study of parts of shapes, points, line segments, angles, things like that. So there is some standard notation here. A point is always named using a capital letter. Okay, so any of those corner points are named A, B, C, that kind of stuff. We had said in the last chapter that if a shape is transformed, then the image is using prime notation. That's where you start to get A prime, B prime, C prime. Okay, we talked about that in the last chapter. Every side of a polygon is a line segment. And so a line segment is a portion of a line between 2 points and is named by its endpoints and placing a bar above them. Okay, so if you notice right here, this would be line segment AB. Okay, a line, which is different from a segment because it goes in both directions, it doesn't stop. A line segment has 2 endpoints. This one is named by using 2 points on a line and placing a bar with arrows above them, just like you see right here. Okay, so that would be line DE as compared to up above was line segment, meaning it had endpoints. And then in the last lesson, we talked a little bit about angle measures. An angle can be named by putting an angle symbol in front of the name of the angle's vertex. And remember, sometimes you can use 1 letter, other times you have to use 3. And so you notice that angle G in this problem that they're talking about is not real clear which angle G we're referring to. So in that case, we would have to either call it angle HGI or IGH. Okay? And note that the name of the vertex must be the second letter, the one that's in the middle, and the order of the other 2 letters does not matter. Okay? So just a little bit of, as you name things as we move forward or you see them moving forward, I want to make sure we highlighted some of this stuff so that you know exactly what we're talking about. Okay? Because it's really important stuff as we move on. Practice to learn for this section, again, is we have not skipped too much yet, so it's all of the problems 219 to 223. Hopefully that made sense to you, and good luck. I hope everything went really well, and good luck with the homework. We'll see you in class.